Let's see. Okay. Hey, Fallen, you're already here. Let me see. I'm still finishing getting things set up on my end. And here, I'm just signing into the YouTube chat on OBS. I think that does it. Okay. All right. I'm back. Everything should be all set here. So, Fallen, you're already here. Let's see. Okay, can you hear me okay? I figure that's a good way to start off a course about ham radio. Seeing if you can hear me. Let's see. Do you know what ham radio is? That's a good part. I guess a good question to start on. Ham radio. Ooh, actually, that's a really good question because Fallen, you're over in Europe, right? Well, anyway, ham radio it's a type of radio protocol for communicating for long distance, usually through like a relay system. It's I definitely have like super delay on my end, but yes, audio is good. Okay, all right. Well, that's actually to kind of be expected. Going from OBS during a live stream, there's like a 30 to 60 second delay, and I don't know why, but anyway, that's to be expected. Oh, RTG, you're here too. So anyway, I just got started. I was explaining what ham radio is. It's, maybe you already know. Maybe you know more about it than I do. It's kind of old-timey stuff. I would say that like 90% of people who are using ham radio these days are either somewhere deep, like in a weird science field, like stationed in Antarctica or on the International Space Station, or they are like old people who are just living out the glory days still. Ham radio is like the way that you would communicate through long distances prior to the internet. Yeah, I think that it had its heyday back in like the I don't know, maybe like the 60s. I'm not sure. So me and a buddy of mine, we've been talking about getting our ham radio license for a long time. There are 3 different classes of it. There is technician, which is the lowest level, and then there is a general license that's a little bit higher, and then there is like advanced license, and that gives you access to everything. Technician class should be enough for everything that I want to do. So a buddy of mine, him and I have been going back and forth for years about how we should get our ham radio licenses. Yeah, that would be cool. You know, like who gets ham radio licenses these days? So finally, we decided we're going to do it. And we enrolled in a class. I learned a whole lot about radio frequencies, more than I ever expected to know. It was very enlightening. What else? What we also learned in the course, though, is that the exam for it is going to change July 1st. So, in order for the entire class that we took to be relevant, we have to pass this by June 30th. So part of the reason why I'm trying to get my ham license, it's a little silly, but my grandfather was really, really big into ham radio, and he... RTG, I was thinking of those radios that were used for news and comedy by CBS and NBC in the 1930s. Actually, yeah, ham radio would have been used in the 1930s. Ham radio you have to be licensed to use. So it wasn't like the old radio broadcasts that were really popular before television. But yeah, I'm sure that CBS and NBC were using them. It's an interesting way of communication, and I'm sure they did use them. Another thing similar to ham radio is CB radio, which is more powerful than a walkie-talkie, but less powerful than a ham radio. With a ham radio, when you properly configure it, you can talk to people like worldwide. But with a CB radio, you're limited to within like a few miles. It's generally was used by truckers, and they would use it to communicate upcoming weather patterns or traffic information to other truckers. Ham radio, like I said, you can talk to people all over the world. And actually, my grandfather, he was big into ham radio. He initially enrolled in the Navy. I think when he turned 18. Oh boy, that was... Well, I don't know. I don't know what year it was, but it was a long time ago. And while he was there, he's sending information down to like a clerical desk via ham radio. And the receptionist on the other side that he's relaying the data to, he kind of fancied her, and the two of them eventually started talking back and forth on the radio for not work-related purposes. Anyway, they got married. That's how Grandma and Grandpa met, was because they were doing ham radio for the Navy back in a long time ago. So anyway, both Grandma and Grandpa are long gone now, and a lot of Grandpa's equipment is still around. And I thought that it could be worthwhile to explore, I guess, this interest of Grandpa's to see what it's all about, what he found so interesting about it, and I guess to connect with my ancestors through a shared interest. Your grandparents are why we need a license now? Yes, I will blame them. Sure, because they're not here to defend themselves. I think you needed a license long before that. I don't know when they started. To my knowledge, as far as back as it went, you always needed a license. I don't know when they started that, but... Anyway. This website, hamstudy.org. It's, exactly as it says. It's a website for studying for ham radio. Let's see. So, I have the mobile app of this on my phone. I've done a little bit of studying on the mobile app, but I figured today we'll pop into the website and actually do some studying here. So we'll do study mode, and if I remember correctly, the way that it works is it just quick fires you questions. Here we go. What is the most common impedance of coaxial cables used in amateur radio? 12 ohms, 50 ohms, 600 ohms, or 8 ohms? Or I don't know. The truth of the matter is I actually don't know. I know a lot about the protocol of how you're supposed to communicate on ham radio. Let's see. Fallen Hunter. I would imagine ham started as a military thing. Makes sense. They wouldn't want just anyone to use it. Yeah, it does make sense. It's actually interesting. Some of the areas where ham radio is still used that I wouldn't have expected. Train operators use ham radio. So when they're going someplace and they need to know if anybody is going to be maybe at the roundabout or in their way, they communicate via ham radio to see what's coming on down the line. RTG. I know that for analog TVs, it was 75 ohms. Ooh, okay. So, analog TV actually communicates on a similar frequency to ham radio. Analog TV is on a higher frequency. So, if that's 75 ohms, let's try 50 ohms. Haha! Okay. I have to admit, without your help, RTG, I probably wouldn't have gotten that one. And we can even look at a little explanation. And the most commonly used coaxial cable impedance for amateur radios installations is 50 ohms. We've pretty much standardized on this value. Just memorize this fact. That's it. It's just that simple. Just memorize it, guys. I don't know. There's no secret to it. There's no like, oh yeah, here's something to help you memorize it. It's just like, just memorize it. Good luck. The other answers are just there to confuse it. Well, that's the point of it. You can share the license. Yes, that's the goal. That's the goal, Fallen. I'm going to get my technician license, and then I'll just send it over your way, and you can use it. Although you're in Europe. I think you're in Europe. I'm pretty sure you said you were in Europe. I don't remember where in Europe, but I don't know how Europe does their licensing. Over here in the States, you have to have a license. There's an organization, a government organization called the FCC, the Federal Communications Committee, or I don't know. But they will come and they will find you. Yes, you are in Europe. Yeah, I don't know how they do their licensing in Europe, but I know here in the States, they'll find you. They'll come and they'll find you because they'll be able to track where you're radio broadcasting from. So you have to get your license. So, I mean, I guess I could send you my license and maybe it'll help you. I don't know. How is the cathode lead of a semiconductor diode often marked on the package? The cathode lead of a semiconductor diode often marked. Cathode with the word cathode, with a stripe, with the letter K, with the letter C. I think it's with a stripe, but I don't remember. Oh, cool. Electrical components can be small, sometimes too small to be able to read letters or words. Might also think of a striped cat. Okay, that's a little bit of a stretch, but sure, whatever helps you. We're doing great here. What is the function of a transceiver's PTT input? I don't remember features here. Switches transceivers from receive to transmit when grounded. Provides a transmit tuning tone when grounded. Input for a key used to send CW. Input for a pre-amplifier tuning tone. Okay, so if I remember correctly, I think CW is just a frequency that's used for clicks. Think, if you will, like if you've got a walkie-talkie and you keep hitting like the send button, like the button you press to talk. When you keep pressing it and letting it go, the other person on the other end of the walkie-talkie is just hearing clicks. Uh-oh. RTG's signal's cutting. Is that a me problem or a you problem? OBS says 0 dropped frames. What about you, Fallen? Am I coming through okay for you? PTT input. Ooh. Push to talk. Its function is used to talk to other amateur radios on a set frequency. Transceiver will be receiving signals on the frequency until the PTT input is pushed, which will switch to transmitting mode. Okay, Fallen doesn't seem to have any issues. I don't know, RTG. I don't know. Maybe move somewhere else in your house closer to the router? I don't know. What is the unit of capacitance? Okay, a capacitor, I believe, is a farad. The volt? No, the volt is... capacitance is a, like, holding. How much can it... What is the capacity of something? How much can it hold? Ooh, or is it the Henry? I think it's the farad. It's not ohm or volt, because that's actively moving electricity. So I know it's not that. I think the volt is how much is being delivered, and I think the ohm is how quickly it's delivered. Anyway, let's try the farad. Yes! The basic unit of capacitance, the farad, is named for the physicist Michael Faraday. Interesting. The volt, basic unit of voltage, of course. Interesting. So a Faraday cage is usually something like a box that prevents a radio frequency from entering. So I wonder... Oh, I don't like this. Henry was inducted into the Hall of Fame, and Faraday tipped his capacitance. I don't like this. That's only going to confuse me further. Let's keep going. What's a transceiver? A device for matching feed line impedance to 50 ohms. A device for converting receiver and transmitter frequencies to another band. A device for automatically sending and decoding Morse code. Device that combines a receiver and transmitter. This one's actually one of the easiest questions that they ask. Transceiver. It is a transmitter and a receiver. Transceiver. Yeah, that one's really easy. Which is equal to 1.5 million hertz. Okay, so in the class that we took, they did give us a little hint. And the hint was that on almost every single question where they're asking you to convert units in the test, you move the decimal point 3 places to the left. So it would be 1, 2, so that would be 1500 hertz. Mega. Oh, I bet it was kilohertz. RTG. Okay, I'm back. I'm going on a trip. Oh, cool. Where are you going, RTG? Approximately 30% of applicants who saw this question over a 2-year period answered 1500 megahertz. Yeah, I'm part of the 30% instead of 1500 kilohertz. And I'm pretty sure that they actually did know how to do the conversion. Yes, I did, but I was just like, oh yeah, whatever. It's going to be 1500, so... Whoops. Whoa, wait. What was the part about moving decimals? I zoned out. Fallen. I could have told you that it's kilohertz. Yeah, I know. I got lazy with it, and I didn't take the time to actually do the conversion over. That was foolish of me. Ushikoro. Okay, yeah, so the part about moving the decimal points. It's because... picking up my brother from his university. Can't say the city though. Oh, yeah. Okay, no worries. But hopefully it's a fun trip. Yes, the part about moving the decimal points. So I took a course, an actual like real class in ham radio, and they told us that in most of the questions, you just move the decimal point 3 places over. That's just the types of questions that they're asking. And I got lazy with that one, and I didn't actually read the answers, and I'm just like, oh yeah, move the decimal point 3 places over. Oh, here's one that says 1500. And I didn't pay attention to really the units. Kilo equals 1000, or automatically 3 points moved. Oh, yeah, you're right. But what if it was going to... what if I had to go from 1.5 million kilohertz to megahertz? Which of the following must be programmed into a D-Star digital transceiver before transmitting? I want to say all these choices are correct just because it calls to me, but I don't think you need to program a codec. I don't know. Your call sign. Oh. We did not talk much in that course about D-Star digital transceivers. Protocol encodes your call sign into every transmission, which technically means that your voice identification is not needed. Because of this, you must program the call sign before transmitting, because otherwise you're transmitting without identifying. That's another thing, is when you are on ham radio, I think it's every 10 minutes. It's when you start a call every 10 minutes, and when you end the call, you have to relay what your call sign is, which is essentially just like your name on ham radio. What is the meaning of the term picket fencing? Rapid flutter on mobile signals due to multipath propagation. Local versus long-distance communications. Alternating transmissions during a net operation. Type of ground system used with vertical antennas. I don't think it's that one. That seems too literal. Alternating during a net operation due to multipath propagation. I think it's gonna be this one, but it's just the way that the question's asked that makes me think that. What was the right answer? Comes from the visual image of watching a light move on the other side of a picket fence. A fence with slats which are separated by a space. You'd see the light appear to flicker as it is periodically hidden by a slat and then visible again. Imagine the same effect, but with sound and signal. That's picket fencing. If someone is mobile and their signal flutters in and out, it's often called picket fencing, though the cause is actually due to the signal taking multiple paths and combining in different ways. Huh, okay. Okay, last edited by KD7BBC. So this is somebody's call sign. Yep, when you get a ham radio license, you get a call sign, and it's like a weird combination of letters and numbers. What does the scanning function of an FM transceiver do? Tunes to a range of frequencies to check for activity, prevents interference to nearby repeaters, checks for messages left on a digital bulletin board, checks incoming signal deviation. This one's actually really easy. The scanning function of an FM transceiver. Most cars have an FM transceiver, well, an FM receiver, but the scan function, when you use it on like your car radio, it just goes through all of the channels and it checks to see which one has music, and it just stops on one that has a signal or a music. So that's really easy. What antenna polarization is normally used for long-distance CW and SSB contacts on the VHF and UHF bands? So VHF is very high frequency and UHF is ultra high frequency bands. CW, like I said, I'm pretty sure that's just a series of clicks, but SSB is the frequency through which people talk. So, or the band, not the frequency, the band. Vertical, left-hand circular, horizontal, right-hand circular. It's going to be either a horizontal or vertical. Radios are quite more in-depth than I would have thought. Well, at least when you only take the exam without prep. Oh yeah, going through like the actual course on the first day when the guy just dumped all this information on us, it was quite a bit. It was quite a bit, but the guy, my head hurt after the first course, but we continued on with that. It was probably about 2 months every Thursday. Oh, Daniel, hey. Hi there, I guess the algorithm had a field day with my interests recommending the stream. I did pass the German equivalent of the extra license in January. Really? The extra license? This is just the technician license, and it's quite a bit for me. So, anyway, once I get my license, maybe I'll chat with you on, I don't know my meters. But anyway, I hope to talk to you out there. Let's see, normally a vertical? It's got to be horizontal. Yep, just think that the long distance implies over the horizon. Horizontal. Okay. Okay, well, that's better than the other one that's like, just memorize it. Why should you avoid attaching an antenna to a utility pole? The antenna could contact high voltage power lines. The 60 Hz radiations from the feed line may increase the SWR. The antenna will not work properly because of reduced voltages. All these choices are correct. I don't know so much about B, but... Oh, Daniel, I'll need to get a radio first. So actually, I was talking earlier that my grandparents actually met through ham radio. They were in the US Navy, and they were communicating back and forth for like Navy purposes, and then they started just talking back and forth through their ham radios just to meet each other. Of course, they were in the Navy, so it was like she was just like she was back on like the base, and he was out on a ship. But anyway, after that, Grandma didn't really stick with it so much, but Grandpa continued doing ham radio all through his life. Unfortunately, neither of them are with us anymore, but I have some of Grandpa's old equipment, and I'm hoping that it still works, so I might have a radio, but I'm not going to try doing anything with it until after I get my license. Yeah, I don't know so much about B, but I do know that this is a problem, because if the antenna touches a high voltage power line, you're going to get zapped. And I know that this one also, high amounts of electricity will cause issues with frequency. It's like trying to use Bluetooth next to a microwave. So I think all these choices are correct. Oh. Any antenna should be far away from power lines. Accident to avoid. Also consider that installing and maintaining the antenna exposes you to the risk of accidental contact with the power lines. The answer about 60 Hz radiations affected from the SWR says they're coming from the feed line. Induced voltages in the antenna might damage the transceiver if they're strong enough or be received as static or unwanted noise. Yep, that's what I thought. But this does not mean the antenna would be malfunctioning per se. The antenna would actually be functioning exactly as intended, turning radio waves into electricity. Yeah, okay, that's true. Oh, pole plus wire equals big ol' fire. Okay, I see. Why is duty cycle one of the factors used to determine safe RF radiation exposure levels? It takes into account the thermal effect of the final amplifier. It affects the peak exposure to radiation. It affects the average. Okay, so I believe duty cycle. If you think of like a wave like you'd see in like math class or like on an oscilloscope, how at some points it's at like a top, like the very highest point, and then it dips down and goes to like a valley, and then it goes back up again. So if you think of like a waveform, I believe a duty cycle is one complete waveform. So I'm thinking that thermal effects aren't going to be part of that. It takes into account the antenna feed line loss. I think that it affects the peak exposure to radiation. I think that because to determine safe RF radiation exposure levels, you're going to want to know how much it's putting off at its the very peak of that. So I think it's this. I guess I'm wrong. Duty cycle affects exposure level, which is what the maximum permissible exposure limits are based on. One person is more likely to tolerate a one-time high peak exposure of very short duration than a lower exposure over a longer period of time. This is where duty cycle is important, because it is a measure of the transmit and non-transmit times, which determines the average exposure. Okay. So I think that it was D. Whoops. You know what? I don't think I'm quite ready for this, but let's do a practice test. What is the unit of impedance? Okay, this one I actually know, because I know like hobbyist electronics. And when you impede a circuit, you do that with a resistor. It slows down, it impedes the electrical current. And I know that is measured in ohms. When you put a resistor in a circuit, you want, it's not, I don't know what a coulomb is. It's not amps, because amps and volts are a measurement of speed moving, or electricity moving, and an ohm would be resistance. Oh no. Okay. When must the station and its records be available for FCC inspection? So I mentioned this earlier, Fallen. The FCC is like it's a government organization that actually they're the ones that hand out your licenses, your ham radio license. And part of that is that if you are transmitting and causing problems on the frequencies, they can show up at your house and say, listen, we want to see your stuff. So only when presented with a valid warrant by an FCC official or government agent. So that's one kind of freaky thing, is that they can come at any time and just be like, show us your stuff. They don't necessarily need a warrant, because if you're like, no, they'll be like, well, then you're banned. At any time 10 days after notification by the FCC of such an inspection. Nope, they don't give you any time to prepare. Anytime after written notification by the FCC of such inspection. Nope, when they show up, they're just like, we want to see it, and we want to see it now, otherwise we're going to take your license back. At any time. Ugh, this is throwing me off. Okay, there we go. What frequency range is referred to as VHF? Ooh. See, this is the part that starts to stump me, as far as antennas and a lot of like the more technical side of things. Stuff like this, like the rules for transmitting, yeah, I've got that all down, no problem. But it's stuff like this that's going to stump me. Frequency range is referred to as VHF. I think and I thought the IRS was spooky. Well, I think that the IRS is spookier because, like, if the FCC shows up and you're like, I'm not giving you anything, you can get off of my property, they just revoke your license. And if you continue to do stuff, then you're in legal hot water. But yeah, they can't throw you in jail. They have to like go through the police to come to your house and arrest you and stuff. But yeah, the IRS is spookier. These guys are just like, don't transmit on the radio. Yeah, Ushikoro, yeah, IRS is scary. I don't like those people. Actually, just, I got, hopefully soon my tax refund is coming in. What frequency range is referred to? This isn't about it. Okay, the frequency range is referred to as VHF. Oh, I don't know right away. I don't know. This one throws me off that it says 3,000 kilohertz, because that would be 3 megahertz. Oh, but they did it up here too. I don't know. I think it's in the megahertz range. I'm gonna say that one. I don't know though. Which of the following are inputs to a satellite tracking program? The last observed time of zero Doppler shift, the Keplerian the Keplerian elements. All of these choices are correct, or the satellite transmitted power. Inputs to a satellite tracking program. I don't know if it would be this one. Oh, actually, no. Satellite transmitted power, inputs to a satellite tracking program. I guess you would use all of these to track a satellite. The last observed time of zero Doppler shift would imply you're tracking its location based on how long it takes for you to get its transmission. Kind of like the Doppler effect, like when an ambulance passes by you when you're in the car. The Keplerian elements, I remember they talked about that in the course, but I don't remember what it meant. And the satellite transmitted power, maybe not, but I'm gonna say all choices are correct. Why do VHF signal strengths sometimes vary greatly when the antenna is moved only a few feet? VHF ionospheric propagation is very sensitive to path length. Multipath propagation cancels or reinforces signals. All the choices are correct, and the signal path encounters different concentrations of water vapor. Let's see. VHF ionospheric propagation is very sensitive to path length. So that's referring to when you're utilizing a radio. the radio waves actually can bounce off areas of the different layers of the atmosphere. And that's, for some of them, how you can communicate for so far. Some of them also go through a series of repeaters. So somewhere near your house or in your town, there will be, at a very high point, a piece of equipment so that when you're communicating, you communicate with this repeater, and then that, because it's so high up, can transmit further than you could from like your kitchen table. But with ionospheric propagation, it's actually able to shoot that radio wave into the ionosphere of the atmosphere, and it actually can ricochet off of that, and it can transmit even further. I don't know if that would be why the signal strength would vary greatly. Multipath propagation cancels or reinforces? Maybe, but I don't know. Different concentrations of water vapor? Maybe, but I can't imagine that it would be wildly different when, like, I can't imagine that would be wildly different if you moved it like 2 feet over. Propagation cancels or reinforces signals. It is very sensitive to path length. Multipath propagation is what they were... it's not going to be that one. That's what they were describing in that question that I failed earlier about picket fencing. When something is moving, the radio frequency might take a different path to get to you. So I don't think this is going to be it. None of these actually seem correct. Whatever. We have to choose something. What is the approximate length in inches? Fallen, you're the best. I know nothing, but I believe in A. That's exactly what I thought. I'm like, I don't know, but you know, it's as good as any. What's the approximate length in inches of a half wavelength 6 meter dipole antenna? Of course. In inches of a half wavelength 6 meter dipole antenna. Well, I don't think it's 112. RTG, I think you were right, Fallen. Okay, so that's 3 of us. All 3 of us believe in A. It's got to be right. If it's not right, I don't know what is. I quit. The approximate length in inches. I don't know of a half wavelength 6 meter dipole antenna. I like that they want to know the approximate length in inches of a half wavelength 6 meter dipole antenna. So like, why is the antenna measured in meters, but they want to know in inches? Ushikoro says B. Oh, jeez. Oh, maybe I am able to change it. I don't know. I'm going to stick with A. We're going to see what happens. It's either 50. It's not 6 inches. That... maybe it is. A meter is around 3.333 feet. The question's basically just how many inches are in 6 meters. No. So I would like to think that that's what they're trying to ask. But the 6 meter isn't in reference to the length of the antenna, but it's in reference to the wave that comes from that antenna or is received by it. The wave itself, from the peak of the wave, and I'm doing things with my hands thinking that people can see me. The very peak, the very top of that wave to the very bottom of it is a distance of 6 meters. So not necessarily the antenna length. Let's see. So $9 feet? John Henry says 9 feet. Let's see. So 9 feet times 12 inches. That would be somewhere right around there. Okay, that works for me. When under normal circumstances, may a technician class licensee be the control operator of a station operating in an amateur extra class band segment? Oh, hey, extra class. That's what Daniel had. Well, the German equivalent of extra. So, the higher level license that you have, whether it's the technician license, general license, or the extra license, and these are just in the US. I don't know if they call them outside of the US, but you get more capabilities with the higher license that you have. So, let's see. Half wave for 6 meters is 3 millimeters. 1 meter is 39.37 inches. Okay, half wave. 1 meter is 39. 39. Oh, 4.5 times 39. So yeah, that would be. Okay. And I think we got it. I'm feeling pretty good on that answer. Okay, technician can be the control operator of a station operating an extra class band segment on a club's station whose trustee holds an amateur extra class license. Oh dang, you know what, now I'm actually thinking about this one. Let's see. Okay. Oh, okay, 3 times 39. Oh, okay, yes. Okay. So 117 inches would be exact, but the approximate length in inches. So I think the closest to that is 112 inches. No? All right, John Henry, you seem to know quite a bit about this. Explain this one to me, because I'm much more knowledgeable on, like I said, a lot of the when can you operate on all frequencies as a technician license, or a lot of the rules behind it. I'm good at those, but a lot of this stuff, like a 6-meter dipole antenna, it gets deep and I get lost. Let's see. So wavelength varies slightly depending on exact frequency. Holy cow, we got some really knowledgeable people in here. Let's see. So wavelength varies slightly depending on the exact frequency. So that actually kind of makes sense, I guess, for 112. Because if it would be 117 inches, 112 inches would be a slight variance. The radio experts are assembling. Oh! Okay, KTG actually is a licensed ham. Wow, okay. RTG is going to be back. Okay, see you soon. 6-meter half-wave dipole. Okay. Okay, equals 3 meters. Now, 3 meters, is that the length of... My understanding is that was the length of the wave. Or the... Well, yeah, the length of the wave, not the length of the antenna. Am I mistaken there? 1 meter equals 3.28 feet. Yep, okay. I did know a meter was approximately 3¼ foot. Or approximately 39 inches. Okay. Just curious, would they allow you to take us all in for the actual exam? Boy, you know, that would actually be really interesting to take the exam, like, like, stream it. So 3 times 39 equals 117. I mean, okay. Like I said, I thought that the 6 meter was in reference to the wavelengths, not the length of the antenna. But, you know, maybe I'm wrong. I mean, that's why I'm doing studying, because I don't know this stuff as well as I should. So... Antenna length correlates to wavelengths. Free answers. Yes, very much appreciated. Like I said, I'm still learning all of this stuff, so I appreciate everybody's input. Okay, well, I think I'm gonna stick with 112 and just hope for the best. It seems like that is the general consensus, I hope. When under norm, may a technician class licensee be the control operator of a state operating in an amateur extra class band segment? Okay, this one I think it's at no time. I don't think a technician can be the control operator of a station operating in the extra class band segment. I think that John Henry. That was, yes, it is. Okay, thank you. Thank you. Cool. That's actually a lot easier, because I know the general, like, how to convert meters into feet, and then, of course, from there I can go from feet into inches, no problem. The wavelength is 6 meter. Okay, all right. Yeah, I can do that conversion fairly easily. That's no problem. So that's actually really useful, because here I was thinking that, like, I had to know something about, like, the actual length of the wave, and I thought that there was some piece of information, and that it wasn't just like a half was dipole is half the wavelength. Yes. Is technician the basic license in the US? Yes, it is. The licenses go technician class, general class, and extra class. 6 divided by 2 equals 3. Yes. Yes. Okay. Thank you, John Henry. I think I figured it out now. Like I said, it was a little bit challenging at first. I got stuck on, like, dipole antenna, and I'm like, well, without having an antenna, I don't really know the differences between them, and I got caught up thinking there's another piece of information I needed to know. But yeah, just converting between metric and US should be no problem. For this one, I don't believe a technician class license can be the control operator, even if the station is operating in the extra class band. I think that a club, I think like a radio club can operate in the amateur extra class if somebody with that is the trustee, but I don't think that the technician themselves can be the one. Riri's here! You're just in time. I'm going through a mock exam, and I'm struggling a bit, and there are a couple of people here in the chat who are super knowledgeable about radio stuff, and they have been a godsend teaching me things and how to figure some of this stuff out. Let's see, that is approximate. KTG, the UK equivalent is foundation, and here we only have to answer 26 questions. So I think over here you have to answer 26 questions correctly. They ask you 35 of them, and I think 26 is the number that you have to get correct. This one I believe at no time. The only instance I think where a technician can operate in a extra class band, I think, is in case of an emergency where like life or property is at imminent risk. What device converts the RF input and output of a transceiver to another band? I don't think it's a high-pass filter or a low-pass filter. Mariri, I have no idea on the subject, so I'm glad you have some experts. Okay, so essentially it's communication through radio, where you can actually like pick up a radio and talk to somebody on the other end. Think like a walkie-talkie, but a walkie-talkie that you can communicate around the world with. It requires a bit more knowledge about like how to configure it and how to interact with the radio frequencies. Oh, there is a lot of math here, yes. It's kind of like if you've ever seen like truckers where they'll pick up the radio and be like, I don't know, Smokey and the Bandit is a movie. Let's see. Logic, the control operator in control. So if something happens or goes wrong, he or she gets fined. Oh no, not math. It's okay because our two specialists here, between John Henry and KTG in here, the two of them understand it very well, and they've been able to help me very much with the maths. So, transverter, a transverter? I knew it wasn't B or C, but I was thinking that maybe it was D. I just woke up from a nap. I can't fall asleep again. You know, I was talking to somebody earlier today. I was like, this weekend, maybe I'll take a nap. And they're like, are you going to take a nap or is the nap going to take you? It's like, whoa. Fallen. I might not understand everything, but it's still kind of interesting. I think it's interesting. I think there's a whole lot of stuff that I don't know about, but it's cool when I learn little parts about it that like correspond with my everyday life. I guess not necessarily just mine, but like I learned about like what exactly AM radio is versus FM radio. Even CB can work over incredible distance in perfect conditions. If napping is your power, what are you without it? Napless, I guess. Yes, CB radio can work over incredible distance. But I think that's... I've heard that, again, perfect atmospheric conditions. I think on like a clear night, for some reason I think nighttime works better. I think that's what I heard anyway. Let's see. John Henry says this is a transverter. You know what? Actually, that makes sense, because if a transceiver is a transmitter and a receiver, then a transverter would be a transceiver and a converter. Okay, yeah, I think that makes sense. Under which of the following circumstances are one-way transmissions by an amateur station prohibited? Broadcasting, telecommand, or transmissions of telemetry, international Morse code practice. Okay, yes, John Henry's correct here. So you're not allowed to be outside of the allocation of your license except in a life or limb emergency. Yes, if you are in like imminent danger of like very, very serious danger, not like the neighbor's dog's barking at me, but like my house is on fire, you can communicate under any class. You can utilize any frequency in order to get a hold of somebody if you are in like imminent danger. Mariri, when I think of AM or FM, I think of that one scene from Sweet Life of Zack and Cody where the guy goes, "Would you like AM or FM?" I admit that I actually haven't seen that, but it's amplitude modulated and frequency modulated. One-way, let's see, one-way transmissions, I believe. Ooh, SOS. Antonio Bosta, hello! I believe it's in broadcasting. I think that it's under broadcasting that one-way transmissions are prohibited, because I know that you can receive one-way transmissions, like you can listen in and not broadcast out. Welcome back, RTG. So I think that if you were just listening in on a ham radio station, which I believe you can do without a license, you can just listen in. He pronounces it as if they were words and not letters. It's silly. I'm going to have to watch that later then. But I know you can listen in on FM stations, and that's not a problem. Or FM stations and ham stations, and that's not a problem. So that would be a one-way communication receiving. But broadcasting, I think that's a problem. Whoops. Which of the following is an acceptable method to determine whether your station complies with FCC RF exposure regulations? By calculation based on FCC OET Bulletin 65, measurement of field strength using calibrated equipment. By calculation based on computer modeling, all of these choices are correct. Yeah, I believe it's all of them. There are individual things that you can buy that'll measure your frequency. Of course you can listen. How else would the aliens hear it? Yeah, you see, Fallen's got it. What happens if you accidentally tune into a super secret station, but don't know? Do they come find you? If you're listening in, no, you're probably okay, but it's probably encrypted, so you're just going to hear like weird staticky noises. But if you're transmitting without a license, yeah, they'll find you, and that's kind of scary. But let's see. John Henry says it's B. By measurement of field strength. All are correct options. Always works for me. I have found in all of my practice testing on these, it is actually not very commonly all options are correct. Antonio Bosta. Yes, you can. I'm ham and CB operator. Glad to see you will be getting your license. I suggest you study and go for the general license right away. Yes, absolutely, Antonio. So the first goal is to get my technician license, because if you've been keeping tabs on things, the exam actually changes July 1st. So I'm trying to get my license before the exam changes, because I took a course in this, and I'm hoping that I can still apply some of that. But once I've done that, I would like to get my general license next. I think that having the technician license, though, would give me a leg up for the general. So yes, starting with technician, and we're going to work our way up from there. Okay, so John Henry says it's going to be B here. By measurement of field strength using calibrated... Well, I thought it was going to be D here, but I guess technically cram for both at the same time. Yeah, actually that's not a bad idea, because I mean, it would get me more familiar with radio frequency stuff in general. Okay, so John Henry says this is B, and I guess that makes sense, because using calibrated equipment, you would have to be able to measure that RF exposure reg. So we'll go with that. What is a characteristic of single sideband compared to FM? Single sidebands SSB signals are easier to tune in correctly. All of these choices are correct. SSB signals are less susceptible to interference, and SSB signals have narrower bandwidth. Okay, so I already know an SSB signal does not have narrower bandwidth, because as you get higher frequency, I believe the bandwidths get smaller. So each one allows you to communicate more. CW, I believe, is the lowest level, and that one is mostly just clicks. And above that is like Morse code radio. Then after that, I believe, is SSB, and that is where people usually talk. You have to pass the tech test before you are allowed to test for the general. Yes, that is correct, John. You can't just jump straight into the general or even the extra class. You have to incrementally take each test. So I'm starting with technician, but I do plan on getting my general eventually. Hopefully sooner rather than later. Definitely in 2026. So let's see. SSB signals are easier to tune in correctly. All these choices are correct. Yeah, SSB signals have narrower bandwidth. No, because above SSB is AM and FM, which they have an even more narrow bandwidth. So SSBs do not have a more narrow bandwidth compared to FM, are less susceptible to interference. I don't think that's true either. I'm gonna say A, because less susceptible to interference. If that was the case, but you can take them both in the same session as long as you pass the tech first. Interesting. I did not know that. I mean, I didn't know for sure, but that's pretty cool. Wow, thank you, Antonio. Okay, I think it's A. What is a relay? Morse code is CW. Okay. That makes sense. So let me ask you this, John Henry. What is the one that I'm thinking of? Because I was pretty sure using even less frequency than Morse code, there was one that's just like a click station, isn't there? I don't know. Help me out here, because I'm a little bit rusty on this. The course that I took ended in the end of February, so it's been like a month. Relay. This one I know, no problem. This is an electrically controlled switch. That one I just know because I've tinkered with small electronics. I associate relay with a switch. Yes, a relay is a type of electric switch. Yeah, I don't have any special way to memorize that one. What's the result of tuning an FM receiver above or below a signal's frequency? Distortion of a signal's audio, change in audio pitch, sideband inversion, generation of a heterodyne tone? Neither of these ones sound familiar, but I think it's not change in audio pitch, because like an FM receiver, so when you're in your car and you're tuning the dial, or I guess cars don't really have the dial anymore, but if you've got like an FM radio with a dial on it and you're tuning in and you're just off of the station that you want to be on, it's not going to change the audio pitch, but I bet it will distort the signal's audio. I mean, it obviously does. I mean, you start getting static and stuff. What type of electrical component consists of conductive surfaces separated by an insulator? Alright, Fallen needs to leave. Good luck with keeping all this info in your brain. Have a nice time, everyone. Thank you so much for showing up, Fallen. Always appreciate seeing you. I'll do my best. I'll make you proud. Yeah. We'll probably be doing this again because, again, I have to pass this in the next 2 months. Antonio, there are some narrow data/digital modes out there. Not sure on the bandwidth of them. Okay. RTG says a capacitor. Ooh, yeah. RTG's right. An oscillator. That one isn't right. Ushikoro likes capacitor. Thank you, Mariri. Let's see. Yes, a potentiometer is like a knob. Is a little bit of, I guess, a lore drop. I used to play guitar, so I had to replace the knob on my guitar. It's a potentiometer. It's essentially a resistor that can be changed as you turn the knob. And a resistor is simply just a piece in an electrical circuit that resists electricity. You get less, it lowers, it's measured in ohms. Let's see, an oscillator, that one would be like making waves. So yeah, capacitor is the right answer. Good choice, guys. What is the resistance of a circuit that draws 4 amps from a 12-volt source? Okay, let's see. Resistance is measured in ohms. Resistance that draws 4 amps from a 12-volt source. I think... Let's see. I think it's resistance over... I think it's 3. I know there's a calculation for this, and I know that there's like a little circle. What is 12 divided by 4? Yeah, I know that one, RTG. But like, there's like a calculation I'm supposed to remember. It's like in a circle, like it looks like a pie, and yes, I'm pretty sure it is 3. But I don't have the actual thing in front of me because I want to simulate this. Mark Deer Hunter, hey, 3? Yeah, I guess it's 3. How can you determine the length of time that equipment can be powered from a battery? Multiply the watts per hour consumed by the equipment by the battery power rating. Divide the battery ampere power rating by the average current draw of the equipment. Let's see. Divide the watt-hour rating of the battery by the peak power consumption of the equipment. 3.14159. Thank you, Marie. That is in fact pi. I would like some pie right now. I would like pie too. What's the best kind of pie? Don't come back with more math. Multiply the square of the current rating of the battery by the input resistance of the equipment. The watt-hour rating of the battery by the peak power consumption of the equipment. Okay. I think that's probably a good choice. I mean, because divide the battery ampere hour rating by the average current draw of the equipment. So yeah, I think that we would want to divide it by the peak power consumption of the equipment, because you definitely, if you're trying to figure out how long a battery lasts, you'd want to figure that out with a little bit of wiggle room, and I feel like B wouldn't allow for that. Watts per hour consumed by the equipment by the battery power rating. I don't think that's it. I think Mark's right. I trust that one. Which term describes the rate at which electrical energy is used? Voltage, power, current, or resistance? The rate at which it is used. It's not resistance. It's not power. Voltage would be... let's see. I think it's current. Because voltage would be how much it's delivering, whereas current would be the rate at which it's delivered. Yeah, I'm pretty sure it's current. Murdery really likes pumpkin, apple, chocolate, and I don't know, I need to expand my pie palette. I was going to make a reference to something, but I think it's from a long time ago. But I went to a pie night once, and there were a whole bunch of these fancy pies. I can't remember any of the flavors, but they were all delicious. I do like pie. I like pie. What term describes an amateur station that is transmitting and receiving on the same frequency? It is not... I don't think diplex is even a thing. It's not full duplex. It's not multiplex. If they are transmitting and receiving on the same frequency, it would be simplex. Duplex would be if you are transmitting on one frequency and receiving on another one. Yes, Mark Deer Hunter, it is in fact A. And the reason behind that is, like when you have a walkie-talkie and you press the button down, if somebody else is talking while you have that button held down, you can't hear them through it. It's just a one frequency. Whereas with ham radio, you can transmit and receive on different frequencies, which would be duplex, so that you can hear somebody else while you're also talking. But in this case, this is just simplex. What is component 2 in figure T1? This is, let's see, right here would be your power source. Here's an LED. This is a resistor. This would be, it's not a resistor. The indicator lamp is number 3. Connector is way too like general. I think this is a transistor. What is the most common impedance of coaxial cable used in amateur radio? RTG! Listen, I got this one right earlier, and it was thanks to RTG. He came in here. That's a transistor in 2. Yes, it is. I had a feeling, but it's been a long time since I've done this kind of stuff. Circuit diagrams. I did that back in high school. What's the most common impedance? Yes, RTG gave us the answer for this one earlier because he said analog TV transmits through a 75 ohm coaxial cable, and that's for television, so a radio is naturally less than 75. It's 50. I want you to know, RTG, if I get that question on my test, I'm going to think of you and just like smile as I succeed. What operating activity involves contacting as many stations as possible during a specified period? That is not a net operation. I'm on the road right now, not driving, don't worry. I just saw a floating bear in the sky and I'm very confused. Marie, now I'm confused. Wait, how? Wow, okay. You'll have to explain more about that. Yes, Mark Deerhunter, it is in fact A. I remember this one because one of the actually all of the people in the course talked a lot about getting really involved in contesting. Simulated emergency exercises, I believe, are performed with military organizations. Net operations, there was one guy that's like a net operator or something. It's not a public service event. I believe those are usually held at like festivals or fairs or something. John Henry, in fact, if you take the tech test remotely and pass, the examiners will ask you if you want to take the general test right then. It saves the $15 testing fee. Oh, that's awesome. Okay, so in that case, maybe I will have to start studying some general stuff just so that maybe I can pass both of them all in one go, because I definitely have to get technician before June 30th. Riri, I don't think it's a real bear, but still lost on why it was up there. Yeah, me too. Even a fake bear. Somebody lose a balloon or something? Yes, this is definitely contesting. What type of transmission is indicated by the term NTSC? A special mode for satellite uplink, a frame compression scheme on TV signals, a normal transmission in static circuit, an analog fast scan color TV. I believe it is. John Henry says it's A special mode for satellite uplink. I was pretty sure the NTSC was for television. I think we can come back to this one. John Henry, if you could explain that one a little bit more. Like I said, I was almost certain it was television, but maybe I'm wrong. What's the symptom of RF feedback in a transmitter or from power supply fuses? The transmitter will stay on the desired frequency. Excessive SWR at the antenna connection. Reports of garbled, distorted, or unintelligible voice transmissions. If you've got radio frequency feedback in a transmitter or receiver. Yeah, RTG. I associate NTSC with color TVs. Europe has PAL. Yeah, that's what I thought too. Let's see. Mark Deerhunter saying D. And I don't know if that's for the RF feedback one or if that's for NTSC. But I was thinking D was going to be for NTSC also. Like I said, I associate NTSC. John Henry saying A. I don't know. It's a good question. Dictator name. I don't know what's going on at all. Good luck with the funny radio wave technology. I appreciate that. I barely know what's going on here, but I'm doing my best. I'm learning what I can. Oh, for the RF feedback. Okay. Okay, Mark says it is D for that one. Garbled, distorted, or unintelligible voice transmissions. That makes sense, because RF feedback, wouldn't it be blowing fuses? Because it's a radio frequency, but I don't think it would quite be damaging electrically. Stay on the desired frequency. That seems more like that would be another electrical. Excessive SWR at the antenna connection. That one, C, seems like it could be a possibility, but they both say D. I'll take their word on it. This one, I don't know. It might be A, but I'm kind of with RTG. I really associate it with TV. Which of the following are typical duties of a net control station? Call the net to order and direct communications between stations checking in. Ensure all the stations checking into the net are properly licensed for operation on that net frequency. Choose the regular net meeting time and frequency. I think they call the net to order and direct communications. I don't think that it's their place to be checking that everybody's properly licensed. I don't believe that's anything. They might choose the regular net meeting time and frequency. I think they call it to order, and I think they direct communication between stations. I think that's what they do. What may happen if the FCC is unable to reach you by email? Nothing. There's no such requirement. Oh no, they'll find you. B? Okay, yeah. Mark says it's B. Yeah, that's what I thought too. Fine and suspension of your operator license. Revocation of the station license or suspension of the operator license. Revocation of access to the license record in the FCC system. There's definitely a requirement. They have to be able to reach you. Of access to the license record in the FCC system. No, they don't just restrict that. I think they actually take your license if you avoid them. Fine and suspension of operator license. I don't think a station license. 3 ohms. 3 ohms? Or suspension of the... I think they can fine you also. FCC doesn't hear back. Bye-bye license. Yeah, that's what I thought. C. It's C? Revocation of the... Okay. 3 ohms. 3 ohms. 3 ohms on... That one from way back there? About, like... I remember there was one that we answered 3 ohms on for, But... Okay. Yeah, I remember 3 ohms from way back. Yeah, that makes sense. I thought that there might be a fine associated with it, but I guess it's just... I guess it's not. But I know they will turn your license off. They'll take it back. Which of the following is good practice when installing ground wires on a tower for lightning protection? Make sure all ground wire bends are right angles. Was email the last option they chose? No operator portal, no phone or message. I think that before email, their preferred way of contacting you was with your regular email or with your regular mail address, that they would send you a letter. So I don't know. There's no operator portal as far as I know. There is a database of FCC licenses, but I don't think there's any way to message people on there. Phone, I don't know if they ask for your phone number, but I know that they want your email and your home address. Let's see. You definitely don't want right angles in your ground wires. Mark is saying that it's C. Ensure that all connections are short and direct. That makes sense. You don't want any Really? John Henry says no. Grounded device usually have ground around the metal chassis, I think. Put a drip loop in the ground connection to prevent water damage to the ground system. Peak only lasts for moments. You want the average. Really? All the way back on that one? I don't know. I mean, I would think that you'd want peak because I guess, yeah, you'd want to overshoot how long your battery's going to last you. I don't know. I know that when I'm building things, I usually want to figure it out based on what the maximum load is going to be on that battery at any given time to figure out how long the battery will last. When installing ground wires on a tower for lightning protection, ensure the connection short and direct. Yeah, I think it might actually. A drip loop in the ground to prevent water damage. Now, we're not worried about water damage for lightning protection. So that means it's not this one. There's a reason it is bad practice to have 90-degree traces on PCBs. Yes, because the electricity can jump. And if you're trying to think for lightning protection, you definitely don't want that. Have you gotten a PO box for your test? No, I haven't gotten a PO box for my test. Is there a reason why I would want a PO box for this as opposed to my home address? I mean, I guess other than like can people just look that up in the database? Yeah, I'm kind of curious, John Henry. Let me know. Yeah, you want your connection short and direct. What causes tropospheric ducting? Temperature inversions in the atmosphere, updrafts from hurricanes and tornadoes, discharges of lightning during electrical storms, sunspots and solar flares. Ducting. It's something with temperature, so I don't think it's the updrafts from. It's not discharges during electrical storms. Temperature inversions in the stratosphere, sunspots and solar flares. A transistor. Oh yeah, it seems like John might be quite a ways back. Temperature inversions in the atmosphere. Sunspots and solar flares. I think it's that one. Which of the following types of solder should not be used for radio and electronic applications? Acid core. It can actually damage the equipment because it's acid. Which is equal to 500 milliwatts. That is 0.5 watts. Again, by moving over the decimal point 3 places, 1, 2, and that'll be 0.5. And it's 0.5 watts. Mark says D? 5 watts? Oh, the acid core solder. Yeah. Which of the following describes a linked repeater network? A single repeater with more than one receiver, multiple repeaters with the same control operator, system of repeaters linked by APRS, and a network of repeaters in which signals received by one repeater are transmitted by the repeaters in the network. John Henry contesting. Buddy, I'm sorry, you are. I think you're way back. I don't know if maybe you lost the stream or something for a little while, but yeah, that was like 10-20 minutes ago. A linked repeater network. Which signals are transmitted. I think it's D. Yeah. Did you guys know that the metric system can also be used for the imperial system? In what way, RTG? And yes, Mark, I believe it is also D, because that is the most well thought out answer of the 4 of them here. That one also, I mean, it makes the most sense for a linked repeater network. It's a series of repeaters. Yeah, that makes sense. Why do most solid-state transmitters reduce output level power as SWR increases beyond a certain level? Let's see. Reduce output power. Oh, that's so you don't damage your equipment. Cannot supply enough current to protect output amplifier transistors. Yes, that's the one. Milli-inches, kilo-inches. Oh yeah, I guess you could RTG. That makes sense. I mean, it's kind of funny. I've never heard anybody do them, but why not? Mariri, I'm glad I was able to stop by for a little bit, but I gotta go now. Good luck on your study, Kaori. You're gonna do great. I know it. Aw, thank you, Mariri. I'll certainly be doing my best. Yes, Smart Deer Hunter. It is C. I knew that it was specifically to prevent it from damaging your equipment. Anyway, bye, Mariri. Thank you for stopping in. I appreciate it. Oh, no. To protect. Yes. Okay. Good. What type of transistor has a gate, drain, and source? A gate, a drain, and a source. I don't think it's a Tesla effect. I don't know what a varistor is. You are reading behind my answers. Yes, John Henry, I don't know what's going on, but you are way behind us. A transistor. I don't think it would be a D, a field effect. Is it MOSFET? I don't know. What I've learned today, RTG, is that you know quite a bit about circuit design. That's pretty cool. I have done a little bit of this kind of stuff, but you're pretty knowledgeable in it. RTG says it's a bipolar junction transistor. I don't know. Mark says it's D. I don't know. I don't know. That one I really don't know. I'm just taking a shot in the dark. Which amateurs may contact the International Space Station, the ISS, on VHF bands? Anybody with a license. FET. Really? Oh, wait a minute. Terry says it's FET. It would be a field effect transistor. And RTG was saying it was a MOSFET, which would be field effect transistor. A type of field. Okay. Well, Mark says it's D. Terry says it's a field effect transistor, and RTG for a while thought it was a MOSFET, so I think that's going to be our answer. This one's easy. I know this one. Anyone who has a technician class or higher license. Because I was amazed when I was taking the course to find out that literally just anybody can contact the ISS if they've got a ham radio. I mean, like, you have to actually schedule it and plan it out and work with NASA to get the thing done, but RTG was right the first time. Yes, thank you all for your help, because that one I'm totally lost on. But yeah, anybody who has a technician class or higher license can just talk to the ISS. I was expecting that you would need more, but once you clear it with NASA and schedule it, then it's easy. Well, not easy, but again, anyone can do it. You don't need like wildly special permissions. Why should a 5 amp fuse never be replaced with a 20 amp fuse? Well, because it's not going to block the same, it's not going to protect against the same amount of juice. The larger fuse would be likely to blow because it is rated for higher current. The power supply's ripple would greatly increase. Excessive current could cause a fire. Actually, yeah, that too. Oh, Grillade. Hi, Grillade. Grill a day. Oh, that's really neat to know. Yeah, it is. I thought it was really cool too. Ushikoro, man, the only thing I'm good at are software and games. No hardware technician thingies. Well, it's okay, because like software is a beast of its own. The two of them interact, hardware and software, but there's learning all about how software works and configuring software and even programming software. It's a beast of its own. The circuit could get damaged if not fused properly. Yes, it could. Which is kind of what I was first thinking, that the larger fuse would be likely to blow. But also, couldn't it also cause a fire? Because if that fuse, a 5 amp fuse, is not... well, the larger fuse would be likely to... Yeah, couldn't it also cause a fire? Power supply ripple would greatly increase. Yeah, I guess that's possible. Yeah, because without a with a smaller fuse, it wouldn't be protecting against the same... Yeah, it wouldn't be able to condition the same amount of power. I think it's B. Although Mark says it's D. Was that the last one? Yeah, Mark says it's D. I don't know. Also, I found that choosing all choices are correct has been not very effective. Oh, and if you're wondering, I am an Electro Boom viewer. Yes, I saw that on that one post. Yes, he's wildly interesting. I haven't watched a ton of his stuff, but I've certainly watched some of it. I don't know. Mark says D. I mean, it could certainly cause a fire, but I would also think that it would be likely to blow the fuse because it's rated for higher current. I'm going to stick with B. Regulates and enforces the rules for the amateur radio service in the USS and the United States. Yes, that's the FCC. I know this one right away. That's an easy one. Let's see how we did. Oh, 28 out of 35, 80%. So that's passing. Terry, a larger fuse would be less likely to blow. That rules out A and B. Okay, that's good to know. Because I think when I was doing I think when I was looking at it, I think there was another one that, like, it's the same question, but, like, the inverse. Like, instead of putting a larger fuse in a smaller one, you use it. Anyway, that's not important. But we scored 28 out of 35. That's 80%. That's good enough to pass the technician test. But I'll also admit that if I didn't have a bit of help from you guys, I probably wouldn't have done quite so well. All of my sample tests that I've done so far have been scoring maybe right around like 20 to 24. So I'm almost there on my own, but I'm not quite there. So, you know, it is what it is, but I've got more practice to do, and this has been a lot of fun. John Henry, no, they try to email you, and then if you do not respond, they send snail mail to the address you registered. Then, if that does not work, they come and knock on your door. Yes, the FCC, I didn't realize that they were so forgiving as far as, like, how many times they'll try to contact you. I thought they just show up. So that's interesting to know. Review questions. Yes, yeah. Let's see. We'll do a quick review here, but I'm gonna have to hit the road soon here. Okay, we got those ones right. Let's see. Which of the following are inputs to a satellite tracking program? Okay, let's see what we missed. Oh, it's just the Keplerian elements. Huh. Okay. I thought it was all of them. Very sensitive. Oh, yeah, this one I didn't know at all. I was just taking a shot in the dark. Oh, it is multipath propagation. Okay. In radio signals reaching the receiving antenna by 2 or more paths. Let's see. Okay. So... okay, that one, now I'm gonna know. Right. This one you can only operate in a different class if it's an emergency transverter. Yep. Interesting. What is this one then? All of these are correct. That was my initial thought, and I didn't stick with it. Because I figured, oh yeah, of course you need a piece of calibrated equipment, because how are you going to come up with a calculation based on this if you can't measure it with calibrated equipment? By calculation based on computer modeling. And again, I was thinking you need to get some of those numbers for your calculation. You would again need the calibrated equipment. So that's why I ended up in C, but my initial gut instinct was D. I should have stuck with it. Which is a characteristic of single sideband compared to FM. Well, yeah, what is that one? Not effective, huh? AM has 2 mirror image sidebands, upper and lower, and a carrier that contains a lot of power but no information. Single sideband omits the carrier and wants it putting all of its power into the remaining single sideband. This halves the single bandwidth and makes much more efficient use of transmitted power. The narrower bandwidth makes SSB less susceptible to interference in the sense that it's a smaller target. Okay, so it was B. It wasn't A. We got the relay, got that one, that one. How can you determine the length of time that equipment can be... Roughly how long your battery would be able to... As an example, you have 24... Somewhere... Oh! I wasn't done reading that. Somewhere between 2 and 24 hours of use for the given setup, depending on how much you transmit and what power output, if adjustable. You want a PO box because your home address will be listed in the FCC ULS database that can be accessed by anyone. In fact, I got my novice license in 1980. I let it renewed. And I went and renewed it in 1986. Okay. Yes, the novice license has been retired since then. But that's good to know, that can be accessed by anyone. But, yeah, so maybe I'll have to look into a PO box. I think this is a loaded question. Because they give you, like, this formula gives you a good idea. So you can see by this that you have somewhere between 2 and 24 hours of use. Okay, so either you're going to be... You have either your lunch break or you have an entire day. Yeah, I don't like this one. This is a bad question, in my opinion. The term, which one is it then? Voltage? Power, also known as voltage times current. Power is... It is power? Huh. Well, okay. Describes an amateur station that's transmitting frequency. Yep, I got those ones. Yeah, this one because RTG. Contesting. Oh, this one was TV. Yes, okay, we were right. I wasn't sure. I was a little confused, but yes, it is for television. Okay, this one makes sense. Yeah, okay. When I was overseas in the military in Japan, it elapsed in 1990. The address is still listed in the ULD with that old FPO, APO address in Japan. It showed it's expired. Oh, okay. You know, actually, I think my grandfather was stationed in Japan for a little while. Or at least, I don't know if he was stationed or if he was just there when his ship was there, but he did spend a little bit of time there. And it's interesting because he got his when he was in the Navy. So it sounds like you and him took very similar paths. Yep, that makes sense. Temperature inversions in the... Okay, that's what I thought for that one. Don't use acid core. That's a network of repeaters. Yep. Okay, this is one that I'll have to remember also. Field effect transistor has a gate, drain, and a source. Is there like an easy way to remember that? Memory aids. Fields have gates. The field's fence has a field of... Okay, this isn't really helpful, but I guess it's better than nothing. Fields have gates. Okay, I think I can use that. Okay. What's the answer here? Clearly the antenna would be a 20 amp fuse would not stop the circuit from overheating. Fuses are selected. Okay, hundreds of amps. This is copper wiring. Glows bright white and melts. This is not recommended to try because it splatters very hot molten copper. You know, fun fact, I once jump-started my car and the jumper cables usually have a fuse in them and these ones didn't, and I stepped away for a minute and that was a really stupid thing to do because I came back out and my jumper cables were on fire. So anyway, every time you jump a car, always stay by the car. Okay, and the FCC. Cool. All right, so there's a few things that I can use to help memorize for future tests. And yes, what else to say? I think that's all we've got in us today. It's been fun. I might do this again because, again, I still have to study this and I still have to figure it out, and I have to pass that exam before June 30th. I would really like to take the exam maybe sometime in May, because I don't want to just wait until the last minute and then it turns out like I'm not on my A game and I end up failing or something. I'd rather take the exam. Ushikoro, tests make me sleep. Yeah, I'm not a bad test taker, so I'm hoping I do okay, but again, I don't want to wait until the last minute and then like I'm not on my A game and I end up failing or something, and then I have to figure out everything. Gorilla Day. I retained exactly no information from the stream, but it was still interesting. Thanks. Yeah, I'm glad you were here. It's a lot. It's a lot. I think that it draws in a certain type of people to the stream. People who are very smart, people who are very knowledgeable about radio stuff. And again, I appreciate everybody who was here. Everybody brought something into the mix, and I think that it is largely due to all of our combined efforts that we were able to score an 80% on this. Oh, Terry, good luck. Thank you. All right, Ushikoro, what's your question? Ask away. You know, it's funny, I'd intended for the stream to just be like an hour, and now here we are. It's been an hour and 42 minutes. But again, it was good. There were so many people here that were so knowledgeable on it that like I just couldn't pull myself away. Plus, I had to see what score we were going to get on this exam. RTG, it was quite an interesting stream. Ushikoro has 2 questions. Okay, I can do 2 questions. But yes, RTG, I think it was an interesting stream also, and I'm glad that you think so too. And again, I learned more about you and your knowledge of circuitry. You were very helpful. It was, like I said, everybody brought something to the mix, and it's our combined efforts that we got this 80%. And Ushikoro wants to know, when is next game? Oh boy. That is a great question. My schedule is a little bit packed right now. It's a little bit wonky. So, I think that if I play a game, I'm only going to have maybe about an hour and a half that I can play. So that kind of throws a wrench in that. But hopefully soon. Hopefully soon. You know, there's a couple of games that I've been meaning to play. Actually, there's too many games I've been wanting to play. But hopefully soon. I've got a good laptop for it now, so I don't have an exact answer, but stay tuned. Question number 2. What's shinier than emeralds? I was supposed to do something, but I forgot about it. Ooh, shinier than emeralds. Diamonds, maybe? I don't know. This sounds like a geology question, and that one I'm not so familiar on. A lot of the science classes that I took were actually more like circuit stuff. We had a thing called Project Lead the Way. It was, I think, largely funded by Lockheed Martin near my hometown. So, yeah, a lot of my science classes, I mean, I took like geology, but I didn't know a whole lot. Or maybe it's a riddle. I like riddles. Oh, it is geology. I don't know, shinier than emeralds. Yeah, I'm gonna say diamonds, but I can't say for sure. I wish I could help. John Henry's about to drop some useful knowledge about the P.O. Box now. Now we already know about the P.O. Box. Yeah. Anyway. No. It's a riddle. Okay, it's a riddle. Shinier than emeralds. Wahaha. Ooh, okay. Shinier than emeralds. Oh, welcome back, John Henry. Shinier than emeralds. I don't know, Ushi, you got me. Oh, I think we're back. Your address will be listed in the FCC database. Oh yeah, that's what you were saying. And that never goes away. Yes, John Henry, you are correct. Anything that gets posted online, you should assume it's there forever, including your home address in the FCC database. So you make a good point. I probably should figure out a P.O. box so that I can mask my identity a little bit and protect myself. So I'll look into that one. Anyway, I hope that I'm actually back and you guys can see this. Ushikoro, I actually don't know myself. Neither of us knew the answer to this riddle, and you're just hoping I'd have an answer for you. Here, right in the middle. There we go. Okay. All right. Other than that little hiccup, I'm hoping that I'm back. But I don't know for how long. Like I said, I should probably get going. I really didn't intend on streaming for an hour and 45 minutes. Mine address is still from 1991 in Japan. Oh, RTG, yes, I am here. Not for much longer though. I have to hit the road. This, like I said, went much longer than I'd intended, but with so many knowledgeable people here to help, I really didn't want to just abandon it. So, with that, I think that I'm probably done. I'll continue to do. I will continue to do more studying, and maybe we'll come back another time and do another test until I'm feeling more confident and can actually crush this test. Again, everybody's been very helpful. Everybody has been very knowledgeable. Yourself, John Henry, that KTG guy, Terry, Ushikoro, Mariri, everybody brought something valuable to this mix, and I really appreciate it. So I think I'm going to call it here, but I appreciate all of you here, and let's do it again sometime soon. I don't know what game I'm going to play next, but I'll figure it out, hopefully in the next week or so. Okay, well, here's hoping that it's still going, and if not, then I'm just talking to myself anyway. All right, see you guys around. Oh, it was a fun stream. See you later. Okay, cool. So you guys were able to see me. Yay! Yes, it was a fun stream. I appreciate everybody, and like I said, we'll do it again soon. All right, bye everyone.